Right, guys, so this is section 6 of the Cairo Bootcamp 2 organized by Blockfuse Labs. And today we are going to go into testing in Starknet. And mostly today we are going to be testing smart contracts. So I believe from the first session, I told you guys there are two ways you can use Starknet Cairo for, right? Either for writing Cairo programs or for writing Starknet smart contracts. So for writing Cairo programs, you can test the program way. For writing Cairo tests, Cairo contracts, you can also test the smart contract way. But the two are not far from each other. It's mostly the same thing. Just that the Cairo contracts is more robust. Sorry, the Starknet smart contracts is more robust because of some certain things we'll be needing. And then if you have also tried testing with Rust, then testing Cairo programs is not going to be a problem for you because it's very, very similar. All right, so my name is Manu and I'm your mentor for this session. And then we're just going to be working on this 4 agenda: intro to testing smart house, then using cheat codes. Now today, what we are going to be working with is Starknet Foundry. So if you are very much familiar with Foundry, that is a normal Foundry with Solidity, then it's very, very much similar. It's almost the same thing here. We are going to check how to test smart contract with Starknet Foundry, how to also test internals, that is using some certain functions, and also using cheat codes. So if you have tested with Foundry, cheat code should not be a new terminology for you. So as soon as we achieve these 4 easy steps, you guys can, I will put it. All right.
Sir, you're kind of breaking.
All right, so where did you lose me from? I noticed it said I lost connection.
When you said, okay, when you said we'll be equipped, like after this class, we'll be equipped with the basic knowledge. So that was where
Yeah. So that means I'm not far from where I was.
Yeah.
Contracts in Cairo, and then you can be able to upskill yourself to learn more. So let's get to the order of the day. So for today, we are going to mostly be looking at the Cairo or the Starknet Foundry book, just to peruse into it a little. And then most things are going to be hands-on. All right, so testing smart contracts. Mostly for this class, we are going to be concentrating on unit testing. So unit testing is just to test the functionalities of our smart contract to ensure that the logic is working correctly as expected. So using unit testing as much as it's a good practice, and it makes your test suite run faster. However, when writing smart contracts, you also want to test their interactions with the blockchain state and with other contracts. So this is a simple example of a smart contract, which just is a simple contract that has this trait. The trait is like the interface, as you all know. It has 2 functions: to increase balance and then to get the balance. So this is also similar to what we are going to be working with today. So what we are going to be using today is a counter contract. We'll just try to increment count, get count, and then some other custom functions that will require us using internals and cheat codes. So this is contract storage, and then the two functions that updates the state. So basic example of testing. So to write a test in Cairo is very, very simple. After you have written your smart contract, all you just have to do is under the test folder, you create your test file. Mostly, if you initialize your repository with the Starknet boundary, then it must have created one file for you in the boilerplate. But then it's safe for you to also create your test file. All right, so the first things you import are this, which we are going to be using from the SNForge standard library. The declare function, the contract class trait, and the declare class trait. So you all know that to deploy a smart contract in Cairo you can do that in like 2 simple steps. First and foremost, you have to declare, which is going to help you get the contract class. Then if you get the contract class, with the contract class hash, you can use the class hash to deploy the contract. So that's what most of what these functions are helping us to do. So the declare is going to help us with this declare function, which you can use to declare a smart contract. And then next is the contract class traits, which we can use to get the contract. Or let me explain the declare result first. So the declare result trait gives us access to this unwrap method, which we can be able to use to unwrap the result that this declare function gives back to us. So when this declare function is called, 2 things can either be returned from the one out of 2 can be returned out of the function. Either it returns a successful result, which is the contract address, or it is going to return an error to signify that an error has occurred while trying to declare the contract. So that's the 2 things that can happen. So it is this unwrap function that is going to help us to unwrap the results that is being given out. So if it is success, then we get the result back. If it's not success, then we get the error. So that's just the use of this unwrap method, which we get from the declare result trait. And also this contract class method, which we get from the contract class trait. So that's the use of this from the Starknet Foundry standard library. So mind you, you might be spinning up your project either with Scab or you use Starknet Foundry. So if you use Scab, by default, there's something you are going to need to add up, which is this. So you have to add this dev dependency, which is the standard library for Starknet Foundry. Yeah. But if you use the Starknet Foundry, then this automatically is going to be your scab.toml, and then you don't need to import any dev dependency again. All right. So the next thing you need now is to import the particular function you need. The particular contract that you're working with. 2 things from the contract. First, you need the dispatcher, which with the dispatcher can be gotten as soon as if the smart contract has a trait. So we get these 2 things. The dispatcher, in this case, we are working with simple contract. So we are going to get simple contract dispatcher, and then we are going to get simple contract dispatcher trait. So with this, it's going to give us access to the simple contract dispatcher can accept the contract address, which is going to give us access to the implementation of that particular contract. That is what we need this for. And then the traits are just what we define for the functions that we can get access to within the the contract. So these are just the two, like I've mentioned, the two most important things we need. So if we get access to all these methods from the standard library, then we import these two guys, which is a dispatcher and then a dispatcher trait. Then we can proceed with the next steps. So the next step is to deploy the contract. So in this function, I think they did two things. They declared and they also deployed, and then they called the method of the contract. But when we are working on ours, we are going to create a deploy function separate so that it's going to be reusable for us to make use of. But let's just explain their concept at first. All right, so in this case, the first thing they do is to call the declare function. So declare is the first step you all know to deploy a Starknet contract, which returns the class hash. So it is the class hash we are going to use to deploy the contract. Remember that. So as soon as we call the declare function, we pass the contract name, which is the name of the smart contract. In this case, you can see what we named the smart contract here, simple contract. So like I said, what we are going to be working with today is testing smart contracts in Starknet. So when you guys have been building, what have you guys been working with? Have you been working with Scab, that is Starknet, and Scab to spin up your project and also do your testing? Or do you work with Starknet Foundry? Which of them? Because this class is for Starknet Foundry, which is like the best you can use for writing tests when building smart contracts. Right? Have you guys tried Starknet Foundry? Smart contracts. Yeah, guys, emojis, please, if you have tried Starknet Foundry before.
Yeah, we have, but not
So
like that, sharp.
Starknet Foundry. Okay. I won't ask questions, don't worry. So I don't know. Do we have to like go over this? But if you have worked with Foundry before, how many people have worked with Foundry in Solidity? All right. Just one person. No, now. It's not possible. So Starknet Foundry is very easy. So let me just explain this. Very easy. Now, it's just a tool that can help you spin up your Starknet projects, write your tests. You can also test. It's also a tool that can help you with your testing, help you with your scripting, just like how you have had that in the normal Foundry. That's the same thing that Starknet Foundry does. So in Starknet Foundry, it has two major commands, two major stuffs it works with, which is SNCast and SNForge. So with SNCast, you can use SNCast to do interactions, smart contract interactions. Meanwhile, you can use SNForge to spin up either a new project or to run a Starknet Foundry test. But behind the scene, it's also making use of Scab. So you can also use Scab and it will also work with it. Are we clear? But this is just a framework that makes it better. But behind the scene, it uses Scab. All right. So what we are going to be working with today is SNForge. And then if you are spinning your projects, if you used to spin up your project in your Starknet project with Scab, all you need to do now is you have to add this to have access to Starknet Foundry standard library and their cheat codes. You need to import this in your scab.toml as your dev dependency. So if you do this, you are going to have access to everything, and depending on the method you are working on. So I've explained this contract, and where we are last is me trying to explain this test. So now we have built a Starknet contract, which everyone is very much familiar with here. Now what we have here is a simple, simple contract. So it's a simple smart contract that increases the balance and also helps us to get balance. It's also the same with what we are going to work with today in our technical session or in the hands-on session. So this smart contract has a trait, which is like the interface that has the increase balance function and then the get balance function. And then here we implement the two functions. These are the implementation of the two functions, increase balance and get balance. So this is the implementation of the traits that we have here. Everyone is familiar with this from previous sessions. So if you have built this smart contract, the next thing you need to do now is to create a test file. So mostly what people do in Cairo, they mostly test like in Rust. So they will advise that you write your test within the same contract, the same file that you are writing your contract, or the same file that you are writing your program. That's how they do it most often. But then for those of us that are coming from Solidity background, I for one, I prefer to write it in the test folder. And simply because from Starknet Foundry, they also create a test folder for you where you can write your tests. And with this, it helps you with separation of concern. So you can work from there. So, but just know that you can also write your test within the file, which is much more easier. All you just have to do is create or add the different attributes for testing, and then you write the test function. And with that, the compiler is going to know that this is a test function. So when you run the test, it's going to run it for you. Yeah. So now when writing the test, these are the two most easiest things we are going to import. So let me just explain the importations, then try to explain this simple test and why we need some of these things we imported. So we are getting the following from Starknet Foundry standard library, which is SNForge STD, right? Not the normal STD, you know. So first and foremost, we have the declare function here. So this declare function can help us to declare a smart contract. So like I was explaining, in Starknet, to deploy a contract, you do it in two simple steps. First, you have to declare. If you declare, it gives you a class hash. Then you can be able to deploy. So first and foremost, we need this method to be able to declare our smart contract. And then this method accepts a byte array, which is the name of the smart contract. So in this case, the name here is simple contract. As you can see, this is the name of our smart contract. Next is this unwrap function. So we get this unwrap function, this unwrap method from declare result traits. So this declare result trait helps to give us access to this unwrap method. Now, why do we need this unwrap method? As soon as we declare a smart contract, it either returns one out of two things. So one is either it returns the result back to us, which is the class hash, or next is going to return an error. So that's why we need this unwrap. So this unwrap is to use to get the results that it gets back to us, to determine what data that we have back, to know what to do. Then next is the contract class method. So if it returns the class hash, then you use this contract class method on it, which we get access to it from the contract class traits. So which is the first thing we have to do before deploying a smart contract, declaring, which is what we did here. So with this, I've explained what we needed from the standard library. So next, you need two things again, which is the dispatcher and also the dispatcher traits for the particular smart contract you want to test. So these are the two things. And then you can get access to it from the contract itself. So as you can see, this name of the this is the name of the contract as it is in the scarp.toml, testing smart contract writing test. With this, so this is the name that was used to spin up the project. And then with this, we can go sub and get access to two things, which is the simple contract dispatcher and the I contract dispatcher traits, which are the two things we have here. So in the hands-on session, we understand this much more better. And then next, we call, after we get contract back, then we call the deploy method on contract. So the deploy method is going to accept an array. So this array is normally the constructor argument, which is what I was explaining before you guys lost me. So the constructor arguments can be anything. You know, the constructor is the first function that is being run when your smart contract is being deployed. So if your constructor accepts any parameters, it's going to need those parameters before it can get deployed or before it can get initialized. So in this case, this is what we are going to pass, an array. In this case, this array is empty, meaning the constructor argument is empty or the constructor doesn't accept any argument before it's going to deploy, before it's going to get initialized. But if your smart contract has a constructor and it accepts arguments, then you have to pass in the arguments here. And then before you pass in the arguments, you are going to serialize those arguments so that it's going to understand more. Then lastly, you unwrap the results that you get back from the deployment. So if you try to deploy, you can also either get the contract address and then this null thing that we don't need, or we get an error. All right. So in this case, if we get the contract address, then we can be able to use the iSimple contract dispatcher, passing the contract address, then we are going to get access to all the implementation within this contract. We are also going to get access to all the storage of this contract within our tests. So this is the first and most important part we need to understand in Cairo testing. So the next thing we need to work with are internals. So let's see a little about internals. So sometimes we want to test function which uses Starknet context. Take, for example, block number or the timestamp, which is the block.timestamp, or the storage access without deploying an actual contract. So we can use the contract internals to have access to that. When we get into the hands-on, this is going to be well explained. So lastly, for the order of the day, we are going to be checking cheat codes. So cheat codes, for those of us who are not new to testing in Foundry, cheat codes are some of the methods which can help us to run some particular stuffs that we need within the tests. So with this, we can be able to use cheat codes to help us out. Like take, for example, we want to fast forward the time. There are cheat codes that can help us with. Or we want to prank a particular user to be able to use the account to sign transactions within our tests. We can also use cheat codes for that. Or we want to, so these are some examples. So these are some examples. Like here, for example, we want to start cheats contract address. So with this cheat code can help us to set the particular account that we want to use to call the methods within the smart contract. So with this, the test is going to know that, hey, this is the account that is being connected. We can also stop or cancel the cheats, etc. So let's just get to the hands-on session, and then we will see this in action. So because of time, we are not going to be testing events. We're not also going to be testing M1 messages from L1, which I have never even tried before. All right. So I already have a project that I spinned up, a smart contract written with Starknet Foundry. And then I'm regretting why I even spinned it up, because you guys don't have much experience with Starknet Foundry. So you should have seen it in action. But trust me, it's not hard at all. You can just refer to the documentation and you are good to go. It's just three main keywords you need to initialize. Once you initialize, you can also build. After building, then you can test. After testing, you can choose to make interaction to a contract state, and then that's it. Okay, so this is the project I'm working on. Can you guys see my screen clearly?
Yes.
All right, so this is the smart contract we have. So this smart contract has three methods, four different methods. Two are getter functions, two are state changing functions. So let's explain the functions in details. First, we have the increment function, which accepts an amount and then adds it to the current count, which is in storage. Next, we have the get count function. So the get count function goes to the storage and reads the current counts that we have. And then next is the increment function after 30 seconds. So this function can only be called after 30 seconds to be able to increment the, for you to be able to increment the count. And then finally, we can get the last increment timestamp. So let's see the last time we incremented a function. This function will help us to know if it's 30 seconds or not. So this is just the simple this is just simple functions implemented within this smart contract. So this smart contract has two state variables, which is count and last increment timestamp. Count is U256 and last increment timestamp is of type U64, which is the default type of block.timestamp. All right, so next we have the implementation of these traits now. So these traits that we have here, this is the implementation. First, we have all the functions implemented, starting from the increment function, accepting the amount. Then it is asserting that the amount is not zero. If the amount is zero, it gives you amount cannot be zero. And then it reads the count and updates, adds the current amount that you are passed, and then increment it within the smart contract. So next, the get count, it reads from storage the count and then it reads it. Next is the function to increment after 30 seconds. So this function is similar to the increment function. It accepts the amount and then it checks, it gets the current time, which is gotten from this method from Starknet, get block.timestamp, which is the current time. And then the last timestamp, which is what we saved in the contract storage as last increment timestamp. It reads it. Then it asserts that the current time, which is the time that we got the current block.timestamp from on-chain, is greater than or equals to last time or the last time we updated plus 30. So this is just to verify that yes, it's up to 30 seconds or above before it can allow you. Else, it must wait for 30 seconds. Then the last assertion is to confirm that the amount is not zero. Then we say amount cannot be zero if amount is zero. Then we do two things to write. We write the new amount or the new count, read the previous count, add the amount to it, write it, and then we write the current time. So the current block of timestamp is what is going to be recorded as the last update. Then finally, we have this function, and then this function can help us to get the last timestamp, which is basically just reading from storage the last time we updated the contract. All right. So next, after you create this, remember always to expose it from the lib.cairo file so that it's going to be known publicly. Because if your smart contract is not accessible publicly, we cannot have access to it within the test file. So next, within the test folder, you can choose to create a test file. In this case, I created a test underscore counter.cairo file. This is not the default file being given to you, but any default file given to you, you can choose to edit it and get the right stuff that is being needed. Yeah. So next, let's check in this file. So we already have this spindle, but let me just clear it. And then we start from afresh. So what are the first thing we need to do? First and foremost, we need to deploy a smart contract or bring the specificities that we need to deploy the contract. All right, so let me just declare this. So first and foremost, I'm going to call the first method, which is the declare method. And we can get the declare method from Starknet's Foundry, which is Starknet Forge standard library. So I can get the declare function here. So with this declare, I can be able to call a smart contract. So the first thing I want to do is I want to deploy the smart contract. So let me just call this function underscore deploy contract. So this function is going to be the function that will help us always to deploy our smart contracts. Then first things first, let me try to deploy or declare the smart contract I want to work with. So let's say contract is equals to declare. I call the declare method. And remember, I told you guys the declare method accepts what? It accepts a byte array. The byte array is the name of the smart contract that we want to deploy or declare. So in this case, this is our smart contract, which is the counter. So let me just get the name here, go back, and then I paste it here. And then remember, it's a byte array. Then next, I'm going to unwrap it. And then finally call the, so before I unwrap, remember I need to have access to the declare result traits so that I can have access to the declare method. Sorry, the unwrap method. So now I can unwrap. Then finally, I'll call the contract class. Which I can also get from contract class traits. All right. So let's proceed. With this, I've successfully declared the smart contract. So next, all I have to do is to deploy the smart contract next. So to deploy the smart contract, I say let's, remember, deployment gives us two things, contract address and then this last one will not be needed. So we can call this contract and then call the deploy method from this. Then we unwrap. But then we are missing something. We have to pass in the constructor arguments. So even though we don't have anything for now, it can be an empty array. So let me just create an empty array. Call it constructor args. And then it's equals to an array, an empty array, which is what we have here. Then I take constructor args and then get a snapshot of it and post it in here. So also remember, if you have anything, you add it here. If your smart contract accepts as a constructor. But you know, mine from this explanation, I don't have a constructor at all. Right? Can you guys see my screen? Is it clear enough? Emojis, please let me know where to get them. All right, so let's go. Back to this test. Now, lastly, this function, we just want to return one thing, which is contract address. Want you to return contract address. So with this, the function is reusable. But then we have a problem here. We are trying to return contract address, but then we are not specifying it in the function. So let's tell our function to return a contract address. And then we don't have contract address imported. So we don't have access to it. So let's try to use it from Starknet. So we say use Starknet. Then we pass in contract address. So this one is the type, this one is the value. All right, so let's proceed. So to proceed, we can go further with testing. Testing the smart contract. But before we can test the smart contract, we have to bring all what is needed from the smart contract. So from now, I can see we don't have access to the dispatcher and then the dispatcher trait also. So we need to bring those two things in here. So let me try to import them. So let's say use. So we are using, what's the name of our contract? To get the name of our contract, let's go here and then we can get it. Sorry, not the name of the contract, the project we are working on. So, and then here I can have access to counter. Then I can have access to I counter I counter dispatcher, and I counter dispatcher traits. These two things, I have access to them. So with this, with the I counter dispatcher, anytime I deploy the smart contract, I will get returned back the contract address. I can pass in the contract address to this, and I'm going to have access to all the contract states, the contract methods, and then I can be able to start writing my tests within it. So let's write our first test function. So in this case, to write our test, I need this attribute, which is the test attribute, to specify that, hey, this is a test function. Then I write function starting with test. So test increment. So first and foremost, let me test that I can be able to increment this. So the next thing I'm going to do now is try to deploy this. So I can just say to get contract address, I can just say let contract address. Told you guys, so that the function is going to be regarded as a test. And all the tests traits, we can be able to have access to some of their stuffs and use them within here. So to test, I first need to have access to the contract states and everything. And to do that, like I said, I need the dispatcher. And before I can get the dispatcher to get me the trait, I need to pass in the contract address. So the first thing I want to do now is get the contract address. So to get the contract address, I say contract address. So I select contract address equals to this. But I just noticed something. I want to make this deploy contract reusable. This should be a function that can be used by any contract. It must necessarily have to be counter. So let me make this dynamic. So all I'll just do here is add a parameter to this name, and then this is a byte array. So now this function is going to start accepting a parameter, and then I'm going to call this. Our function is what? This is the counter. So it's counter now I want to deploy. So with this, I can deploy counter and then get the dispatcher and have access to it. So next to dispatch, I'll say let's counter contract equals to I counter dispatcher, and then I pass in the contract address in here. So fingers crossed, this should work for our setup. So, but to be sure everything went fine, we have to call the SNForge test so that it can be able to run the test. Now, mind you, if your function doesn't have this attribute, if you run the test, it's going to skip it. You won't know about this one. You will look at it as a test. You will just read it as a normal function. So always remember to do that. So let's try to run it with SNForge test. If everything passed, it means our setup is okay. Okay, so we have an error. So what does the error say? Ambiguous method call, more than one applicable trait function with a suitable self. Wrong number of arguments, expected one, found zero. Okay, so this is the mistake. I forgot to write name in here so that he knows that it works with name. So let's try this again. All right. So our setup is good to go. Everything is finished and it show one test pass, though we didn't write anything here. And then I just want to highlight a few stuff that you can do the alternative way. Like take, for example, to deploy a smart contract, you can also use the deploy syscall. So the deploy syscall is like a low-level call to do that. You can also use that method here. And these are not stuffs that I made use of. All right. So successfully we have deployed our contract. That means we have access to the method, we have access to the state. So let's try to call our first contract method now. So this guy is already writing for me. So first, let's get the initial count. So the initial count is going to be the count before we started, which we know the count is zero, but we just want to verify from state that our initial count is gotten. So together we get counter contracts dot get count. With this, we have access to the count, right? The initial count. So after getting the initial count, Copilot is helping me out, but I don't want his help. He's telling me to check if the initial is equals to zero and then confirm that the initial should be zero, which I can also assert to do that. So let's just work with that. And then I call the increment function. So to call the increment function, I just call counter.increment, passing an amount. It says we should pass 5, but I want to pass 50 instead of 5. So if increment goes well, next I'm going to do is I'm going to try to check the count after increment. So new count or updated count should be, so let's call it updated counts as suggested. Then we have access to the method. So we can get counts now. Nice. So next, let's assert that the updated count is 50. So we can just do that here. And we can also choose to assert that the updated counts let me call it counts. So we can choose to say the updated count is greater than initial count. So if it is greater than initial count, it means everything went well and we are good to go. This might be a little bit confusing for some people, but we'll come back to explain this. I guess the new thing I just brought here is the assert keyword, which most people have already worked with. So let's cancel this and then try to run the test again and hope it passed. It says value does not fit within the range of core field 252. Where is that? Line 14. Okay, starting from here. think this should be it. All right, so the problem was from the error message we are going to send back. So it was too long. Remember, it's FEL 252, and FEL 252 is just 31 characters. So that's why I had to reduce it to count to initial counts. Let me just say not updated. So with this, we have written our first test, and then we'll try to go over this again. So first and foremost, what we need to do is to deploy the smart contracts. So we try to deploy our contracts, which is from this function that we created, the function that accepts a byte array as the name of the contract. Then we use the dispatcher to have access to the contract implementation. We check the initial count. So this get count is a function that exists in our smart contracts. Remember, we had this function here, get count. So if we do not add this function within the thread, we are not going to have access to it, right? So next we try to use this assert. So this assert is just a method that helps us to confirm like two different values if they are being correct. It's two things. Is you can use, there are different type of them. Assert whether is equal, assert whether is not equal, assert whether is greater than. But if you want it to be like explicit, you want to explicitly define what you want to do yourself, you can use this normal assert and then try to compare if this is either equals to this. So with this, we are checking whether initial count is equals to 0, which is supposed to be 0. Then next, we call this increment function, which is also a function within our smart contract that we got. And then we try to check the states of our count again to see if it has been updated. And then we assert that we updated it to 50 because this is the amount we passed, and before we had 0. So we expect now that it should be 50 because we know it's 0. Then next, we also assert that our updated count, which is the new count we have now, is greater than the first initial count we have. That is saying we are trying to check if 50 is greater than 0. So if it is, all things being equal, it means our test went fine. So this is just the basic concept to unit testing in Cairo. All right, cool. So next, now let's try to test for assertions or for requirements or for if statements, tests that are supposed to fail. Let's test for failure now. So instead of we trying to test that we are incrementing after 30 seconds, this is a long function. I don't want to write this. So next, I want to teach you how to use another attribute. So this attribute should help us test for panicking to be sure that all our panics are working correctly. So in this case, I want to work with the test for this counter. And remember, before we can increment count, we are checking that the amount is 0. So I want to be sure that it is failing if the amount being passed is 0. So that's what I want to work with next now. All right. So back to the test contract. I write my test attribute again. Let me close this one. Or I will be copying and pasting a lot of things, so no need. So let me try to test. Cannot add, cannot increment 0. right? So that let's be sure that our panic is working fine. So we want to be sure that it cannot increment 0. First thing we need to do, we need to get these two stuff, get the deployment, then get the first initial count. Then this. So you guys understand all these things, right? So no need of explaining this one. Next, I got the initial count to be sure that it's 0. Now I don't need to. Now next I need to do is I need to call the increment method. So I think I don't even need to even check the count. So let me just try to increment. So I just say counter contract dot increment 0. So if I put this should fail. So the only way I'm going to tell this contract that, hey, I'm expecting this contract to fail. You guys know that this contract is going to fail. This function is going to fail because this is 0. And then anytime it calls this method, it first check whether amount is 0, which in this case amount is 0, right? So to make this possible, all we just need to do is we need to add one more attribute here, which is the should panic. Should panic, we are also going to pass what we are expecting it to panic with. So let me add the attributes now. So this attribute is should panic. Good. So should panic, and then I'm saying expected, which is what I'm expecting the contract to return, which is more like the error message is this. Now the error message must match the error message I have here, which is amount cannot be 0. And it's the same thing I also have here, amount cannot be 0. So if it is expecting that this test should panic with this error, because once we try to call this method, it's going to give us this error. So if it gives us this error, it means this test has passed correctly. So let's try to check this out. I'm sure those of you that have worked with Foundry will say, hey, this is a sweet method of testing error cases or panics, because this sounds much more easier. So if this goes well, our test should pass. So we should have 2 tests passing. All right, bravo. So we have 2 tests passing, which is to increment that test cannot increment with 0. So we assert that this is 0. But how about if we try to change this expectation? Let's see whether it will pass or not. Can you see? It didn't pass. Because it's saying amount cannot be 0, but me, I'm saying amount cannot. That means the expected doesn't rhyme together. So let me just do the command Z and then get this. And then try to test this again. Then we will not try to test. We are now, and then we are done for the day. So the final function would be the test to check if we can test after 30 seconds. So we are going to try to use a cheat code to like spin up the time. So we increment the time to like plus 30 seconds. And then we try to call the function immediately to ensure that 30 seconds has elapsed. So hope we are good to go. So starting with this attribute, the test attributes. Now let's get to the function. So the function tests can increment after 30 seconds. Then next, I copy and paste the most important thing, which is these 2 guys. Paste it. Then next, we are going to try to increment. Now let me try some things and make sure it fails. So So I'll say counter dot increment. I want to increment by 50. Then next, I would also try to increment by 50. Okay, no. I'm not calling the increment function. I'm calling increment after 30 seconds. That's the function I'm calling. So let me take this one out. Okay, so now we are calling the test if we can increment after 30 seconds. So this one, to check the last time that we added, right? So let me just try to call this function twice, or let me call it once. Then let's be sure that the count is updated. So everything will go fine. Let's see. Then let's try to call the function twice before 30 seconds and see what's going to say. So fingers crossed, if we just call this function. Okay. Same old problem. So Copilot doesn't know Cairo very well. So that's why in Cairo you have to marry docs. Oh, so why is this working? It's saying test must wait 30 seconds. Did I call it twice? Oh no. So why is it saying let's try to study our contract, what our contract said you should do? So our contract says you should check the current time and then check the last time it was updated. So after it checks the last time, it should assert that current time is greater than last time plus 30. So on and on, this last time is supposed to, the current time is supposed to be greater than the last time now. Okay, no, the last time is just 30. So it's almost the same. So two of them would be like 0, 0. Okay, so let's try to change the time now. So I want us to make use of a cheat code that will help us to like prank the time or to cheat the time to go after 30 seconds. So that's what I want us to do now. So to do that, we are going to use the cheat code, which is a cheat code that can help us to set the block.timestamp. So this is a cheat code now. We can get access to this cheat code from the SNForge standard library. So this is the SNForge standard library. And then I'm going to import two methods. The first method in this case is to start cheat block timestamp. So start underscore cheat underscore block underscore time stamp. So you guys can check the Starknet Foundry documentation. You have access to more and more cheat codes depending on your use case for testing. I'm only using the cheat code needed for this particular test or my contract that I wrote. So you don't, I don't know your contract use case. You might know what cheat code you want to use, but trust me, they are very straightforward. So if I bring in the start cheat block timestamp, I'm also bring the stop. So anything I start, I stop it. All right, so the two are in. Then before we call this, let's start the cheat. So we say start cheat block timestamp. So the start cheat block timestamp are set two parameters. The first parameter is the contract address. Yep. The first parameter is the contract address that we want to cheat the time. And then the second parameter is the time that we want to make it to be. And then the time is in epoch. Remember that. So let's do this. Call this. Now, what I want to work with now, I pass it in. In this case, I pass in the contract address I want to work with. So I say contract address. Then next, what is the time I want to cheat to? So the time I want to cheat to will be the last update time plus 30. So let me just do that. Say let's go to last. So last increment timestamp is equals to counter this. So what I will do now is say last increment timestamp plus, let's do 31, since that's what it suggests. So let's just add the time to 31 so that it will be above 30. And then we try to test that this function is going to work after 30 seconds. So fingers crossed, go through. Yeah, we got a question. Okay, not a question. Okay, so this meeting is scheduled to end very soon. So maybe after this test, we call it a day, which is what I even said initially. So back here, I'll just try to call this test with SN-Forge test. So SN-Forge test is what you use to call to run your tests in Starknet Foundry. And then it builds it, and then it runs the tests. It says start cheat block timestamp is defined multiple times. Where did I define it multiple times? Oh, I'm supposed to put stop here. Okay, so finally, I even forgot. I'm supposed to stop it. So let me stop it. So stop cheat block the timestamp, and then I pass in the contract address, and that's it. I have stopped the contract. So let's run this again. All right. So all our tests have passed, meaning everything has gone well. So we've successfully made use of one of the cheat codes today. We also tried out declaring, deploying with our tests. We checked the minimal things we need to deploy in Starknet contracts. So there are more cheat codes you guys can learn. Trust me, when you are working with Foundry or Starknet Foundry, cheat code are your way out. So with cheat code, you all those hard things will simplify everything for you, and you are good to go. So with this, we are done for the day. So you guys can keep checking it out. Test with Cairo. Remember, as soon as you write your smart contract, you go with test immediately to be sure everything is working. So what we just did today is unit testing to be sure our logic and everything is working fine. And we are good to go. So thank you very much, guys, for your time. Thank you for attending the class. See you around.